The last problem in section 2 is probably going to clear some things up for you on the homework when you get to things that look like this. So it says, what is the simplest form of the cube root of 5x squared divided by 12y squared z? So then I look at my answers here, and wow, they look a lot different than what they started off as. So first of all, it's saying simplest form. And I know that simplest form does not include radicals in the denominator. So in this case, I can probably eliminate choice B. So in this case, if I was a guessing person, because I had no idea what I was doing, at least I'd have a 33% chance of guessing it correctly. Okay? We need to know how to do this problem correctly, though. And this hopefully will clear up some of these later problems as you make your way to number 51. So what we need to do is remember two things. First of all, we can reduce fractions that are inside of roots. And second, we can split roots into a little root divided by a little root, no matter what the index on that root is. So in this case, because it's already written as a big root, I'm going to try to reduce this. Does it reduce? No, it doesn't actually. 5 divided by 12 is a fraction that does not reduce. X squared divided by, there's no x down here, so that doesn't reduce. And then I have y squared z, there's no y or z up here either. So this is already reduced, which is kind of a bummer. So that means what I need to do is split this into a cube root of 5x squared divided by a cube root of 12y squared z. Notice letter B. Yeah, it's the same thing. But is that simplest form? No. I have to reduce this. I can't leave a radical in the denominator. So B still isn't the right answer, even though I'm looking at what answer choice B is. What I need to do is, like square roots, if I had 1 over the square root of 5, like this, we talked about this one last time, I have to multiply by a fancy 1 to get rid of that square root. To undo square root, I have to have it be squared. So in order to make the square root of 5 squared, I multiply by the square root of 5, top and bottom. But on this one, I'm dealing with a cube root, which means to undo cube roots, I have to wind up with that cube root being cubed. So that means I have to multiply the denominator times itself 3 times. If I do that, then the cube root will disappear. So, let me change colors here because purple's not working for me right now. Third root 5x squared, third root 12y squared z. My fancy one is going to be the third root of 12y squared z squared. So now what I have is this thing squared times the same thing, which gives me that thing to the third power. So I have the cube root of 12y squared z now to the third power. And the third power in the cube root will disappear, and I'm just left with the 12y squared z in the denominator. So what I did basically was say that what I have sitting here is something to the first power. I want to turn it into something to the third power, so I multiply it times itself a couple more times. This thing to the first times this thing to the second, I add the exponents and I get to the third power. Okay? So now the numerator, this is a fancy one, so the numerator we have to have the cube root of 12y squared z squared. This is where it gets tricky. Because of the fact that I'm writing it like this, I need to remember that what I actually have going on here in the numerator is this. So off to the side, I'm going to change colors so I don't get confused. What I have is the cube root of 5x squared times the cube root of 12y squared z, and I'm squaring that, so I have that times itself. the cube root of 12y squared z. Right? Something squared is itself times itself. Right? Okay. So now that I've written this out like this, I can, since these are all the same index, multiply all this stuff together. So I have 5 times 12 times 12. What is that? $720. That's still under the cube root. I have x squared times, oh, that's it. So you just get x squared. Then I have y to the 4th and z squared. So that's my new numerator there. And I've gotten rid of this cube root in the denominator. So I'm in pretty good shape right now. All I need to do is simplify this numerator and then reduce if I can. So I'm looking for perfect cubes. Is there a perfect cube that goes into 720? What is it? Yeah, I think we did this one yesterday, 720. 144 is the biggest perfect square. So perfect cubes, we're talking about 1, 8, 27, 64, 125. 216 is another one. Does that one go into 720? How about 125? What about 64 or 27? 125 doesn't work. So 64? Eight times what? 8 times 90. Is there another perfect cube in 90? It would be 8 or 27. No. So 8 times 90. So I'm splitting the 720 into the cube root of 8 times 90. Is x squared have a perfect cube in it? No. So times x squared. What about y to the 4th? Yeah, what is it? So times y to the 3rd times y. How about z squared? Nope. So times z squared. Where am I getting y to the 3rd from? I'm turning y to the 4th into a perfect cube times something. Y to the 3rd is a perfect cube times y is y to the 4th. Okay, so continue. Take the cube root of the things you can take the cube root of. We can take the cube root of 8, we get 2. The cube root of y to the 3rd is y. Can't take the cube root of anything else, so I have the cube root of 90 x squared y z squared divided by 12 y squared z. Does that reduce? Yeah. So we get 12, 2 divided by 12 is 1/6. The y is still up top, or is it? We have y divided by y squared. Subtract the exponents and you get y to the negative 1st. Or you can think of it as canceling. The y here cancels with one of the y's here. You're left with a y down in the bottom. That z is still down in the bottom. I've reduced the 2 and the y and I'm left with the cube root of 90 x squared y z squared. So there's your answer. This was a multiple choice problem though, so which one is my answer? A. So the point on this problem is, I know it gets disgusting very quickly and there's a lot of work to do, but when you have a cube root in the denominator as we had here, you're not just multiplying by a fancy 1 that is the denominator exactly. You have to make the exponent match the degree, and that's what we did here. We said this thing is to the first power. So I need to multiply it times itself 2 more times to get this thing to the third power, so that the 3 here and the 3 here wipe out, and I'm left with the 12y squared z. It's a fancy one, so what you do here, and then you multiply it all out. Then you simplify as we were doing in the beginning of the section, and then you reduce it down to get to your answer.